CRC table.
Talked about it yesterday.
I'll take a detention.
All right, boys and girls, this is big time math. I need everybody paying attention. We are on part 3, which is on the back of page 27. I want to remind you that you have already done some problems that look like this. You have done a problem. Now, number A is the log base 3 of 4. But you have already done problems like the log base 3 of 9. You've already done that problem.
Would that just be a
When we take a quiz next time, a problem like that's going to be on it, because we've done those. What does that equal? 2. Very good. 3 to what power is 9? The answer is 2. Now, this one looks exactly the same. It's set up exactly the same way. The problem is, when I loop-de-loo it, I get 3 to the x equals 4. Well, that doesn't work out so well, does it? So here's how we're going to handle that. Everybody pay attention. You've never done this before, I don't think. It's real easy. And thank God there were some really smart guys a long time ago that figured all this out. What we're going to do, we loop-de-loo it. Now I'm going to take the logarithm of both sides. So I'm simply going to put a log on both sides. See that? I just put log here, log here. Now, see this? That's an exponent. What can I do with it when it's part of a logarithm expression? It becomes a coefficient. So now it says x log 3 equals log 4. And if I want to know what x is, I'll just divide both sides by log 3. So x ends up equaling the log of 4 over the log of 3. So I'll go to my calculator, and remember, Ferris or somebody, when you asked me yesterday if we needed to close the parentheses?
Oh, yeah,
now we do. So we're going to press log 4 and close the parentheses, people, because then you're going to say divided by log 3. And you should get 1.2619 as your answer if we round it to the nearest 10,000. Sure. The biggest mistake that's going to be made is you're going to forget that parentheses, and you'll get the wrong answer if you do. So get in the habit of, when you press log 4, close parentheses, and then divided by log 3. Did those of you with calculators get this answer?
Yes.
That's it. That's all there is to it. It's that easy. So when I look at problem B, and it says log base 7 of 11 equals what? What does that equal? How will I start? First I need to loop-de-loo it. So it's going to say 7 to the x equals 11. Now, if this number had been a 49, I'd be all set. But it's a weird number, so now I need to use my calculator. So what will I do now?
X log 7.
Well, I'm going to log both sides.
And then divide by log 7. Oh, we'll move the x.
The x out in front. And then divide by the log of 7. So x equals
1.23.
the log of 11 divided by the log of 7. I'll type that in on my calculator.
1.323.
If you see that, like, from the beginning of the problem, that the 11 and like 7 August isn't going to go into 11. Can you just start by putting log 11 over log 7?
Okay, now, Joe has made an observation that actually mathematicians for hundreds of years have made, because he's a great mathematician. He says, look, Mrs. Ford, we've done 2 examples. This was the first one. This was the second one. And you took me through a bunch of steps. But in the end, this is what I typed into my calculator for that one. And this is what I typed into my calculator for this one. So the next time I see one of these problems, like log 0.4 of 12, instead of going through all the steps, can I just say what?
Log 0.4 over log 12.
Now watch it, you gotta be real careful.
Log 12 over log 0.4.
Exactly. It's gonna be log 12 over log 0.4. That is actually called the change of base formula, and it works every single time. The only caution I have for you is you gotta make sure you get the numbers divided in the wrong order. So a way you can remember that, if you choose this route, a way you can remember it is, when I write this, just any logarithmic expression, this number is down below. Would you agree? It's the base, so it's down below. So when I convert it, it is the below number. So this is going to be the below number. It starts out below, it ends below. So I'll type that in.
-2.
That one's going to be a negative, and that's fine. They can be negative. I got negative 2.7119.
Yeah.
Now, let's see if you can do D, E, and F. See if you can figure out how to type in D, E, and F. And you can go through all the steps, or you can use the change of base shortcut formula, whatever you want to do. So Max, that would be you too, sweetie. Will you jump in?
Yes.
Okay. Don't forget to close your parentheses, please. And tell me if I make a mistake. That was a mistake. What do you think about those? Are those okay?
Yeah.
Everybody good? All right, 2 more problems. These are in your book. So if you have a book, please look at it. If not, you'll just have to get what I can get up there on the board. This is number 54 on page 318. And they give me a formula. These are real life problems, real world applications. And the formula looks like this. And I is the intensity of the light, and X is the depth. So what this formula is doing is telling you how well you can see in Lake Superior. Obviously, the farther you go down in the lake, the less you can see, right? So this gives us the equation. Somebody's developed this equation and said, okay, I is the intensity, X is the depth. There's the equation that relates those. The question is, what is the intensity at a depth of 10 feet? All right, now, you guys can do this. You know how to do this. Here we go. We have an equation, and they've given me this 10. That 10 is going to go into that equation somewhere. Where's it going in? Is it going in for I, or is it going in for X? X. Why do I know it's going in for X? Because this is the depth, right? And I'm trying to find I. So my equation, I'm just going to put a 10 right here. Okay, well, I got a calculator. I can figure, well, actually, I can figure that out without a calculator. So it says log I over 12 equals negative 0.125. What's the base on this? No. The base on the logarithm. 10. Remember, if there is no base, it's 10. Now let's loop-de-loo this. What does it say if I loop-de-loo it? 10 to the negative 0.125 equals I over 12. What's 10 to the negative 1.25 or 0.125? You can type that in. 10 raised, when we use this button, negative 0.125. Did you get 0.7499 basically?
Yes.
Okay. So we need to know what I is. So all you have to do is take that number and what? Multiply by 12. And the answer is 8.9987. That is your intensity. Okay, that wasn't too bad. All right, one more, number 52. And I think the sheet says we're just doing A. All right, so 52A. Have another formula. This formula is this. And A is the amplitude. Oh, actually, you don't even need to know what it all stands for. Because in the problem, they tell you A is 250. B is 4.25. And T is 2. And your job is to find R. So this is actually a logarithmic equation that describes the Richter scale. Do you know what the Richter scale is?
Yes, earthquakes.
Earthquakes. So this is describing the magnitude of an earthquake. And it's logarithmic. The magnitude of the earthquake. So we want to know what is the magnitude, what is the R value, if we know all of these things.
I hit this thing on my keys, that's what it is.
Okay, can we turn it off?
Yeah, I'm trying to.
So R equals the log of 250 divided by 2 plus 4.25. Now, are you following that? You see what I did? This is the equation. They gave it to me. No one's asking you to write your own equation. They give it to you. They gave you these three values. So I plugged in my A, my T, and my V. And now I'm just going to go to my calculator and see if I can type it in. I got 6.3469. So if this were a real earthquake, we would say it was about a 6.3 earthquake.
Just bad.
Oh, yeah, earthquakes are bad.
What was the highest?
Okay, yes, Max.
So I'm a little bit confused. So you reduce 250 by 2 down to 125.
Uh-huh.
And then you do log, and then obviously the base for that's 10.
Doesn't matter, because we're using our calculator, but yes, the base is 10. So we just type log 125
Okay.
and get an answer to that, and then add the number on the end.
Okay. I understand.
Make sure you close your parentheses when you log it. When you take the log of 125, close the parentheses, and then add your 425. Okay? All right, so I got some review problems I thought we'd do now. If I can find them. These say different things at the top, practice, quiz and stuff. They're not. They're practice. On Monday, or whenever I see you again, I'll have an actual practice quiz for you. These are just random review problems that are gonna help us get smarter. I've actually already videoed this.